or 5, observational studies and experiments. The first one is called confounding. We got our definition boxes that we'll fill out here in a second, but here's one of the stories that we talked about earlier this chapter. Remember when we revealed the teenagers that ate with their families at least 5 times a week are more likely to get good grades in school? It's not appropriate to say that just because you eat with your family more often will cause your grades to improve. There's other possibilities of why their grades were better. It's like maybe they're not involved in so many activities, all this stuff, but that's called confounding. Confounding occurs when 2 variables are associated in such a way where their effects on a response variable cannot be distinguished from each other. When 2 variables are associated in such a way that their effects on a response variable cannot be distinguished from each other. It's like, hey, did eating with your family cause you good grades, or did the fact that you actually do all your homework cause the good grades kind of stuff? It's like just because one thing happened doesn't mean it caused the other. So we'll kind of see how confounding works when we get into some more examples. A treatment is a specific condition applied to the individuals in an experiment. That's like how you treat people. If you're going to do an experiment, the treatment in our little in our little video was they gave them the whift, so like how that was applied, that was the treatment that they did, and they pumped them up and they told them all this stuff. And then the experimental unit is the object to which the treatment is randomly assigned. Whatever you assign that treatment to, that's the experimental unit. When they're human beings, we usually call them subjects. So in the whift example, those human beings were the subjects. That's who they were doing the experiment on. Like sometimes they do experiments on plants. Sometimes they do experiments on other things, So that's the experimental units. So a lot of long stories, but we'll just fill in the blanks to the answers, of what the stories go. So hang with me. All right, can ADHD be linked to mothers who smoke? You guys know what ADHD is, right? Attention Deficit Hyper Disorder or whatever now. In a study of more than 4,700 children, researchers from Cincinnati Children's Hospital Medical Center found that those children whose mothers smoked during pregnancy were more than twice as likely to develop ADHD as children whose mothers who did not smoke. Based on this study, is it reasonable to conclude that a mother smoking during pregnancy causes an increase in the risk of ADHD in her children? Explain your reasoning. Well, here's the real question. Is that the only thing that you think could have caused the ADHD, or could there be other scenarios? There's definitely other things that could have caused it. So we will say no to this. And then they just make up a possible confounding variable. It is possible that women who smoked during pregnancy had less healthy diets. So that's just one confounding variable they said. It's like, hey, maybe the people who smoked also didn't eat as well as the people who didn't smoke. It's not saying that's what happened, but that is a possibility. So the eating poorly could increase the risk of ADHD. If both of these are true, then we would see a relationship between smoking and ADHD, even if smoking has no effect on ADHD. So this is just kind of like how homework will be. They'll have the drop-downs that we're used to. They make up a situation of a confounding variable, and you have to fill in the blank with increases or decreases kind of stuff. But they just made up a whole different confounding variable. It's like, hey, what if those other people didn't eat as well? That could have happened. So let's see another one. Does happiness prevent heart disease? In a study of a random sample of that many adults from Nova Scotia, Canada, researchers interviewed each participant and said, among other variables, assess their attitude using a formal psychology survey. So they were just asking people questions, and they were also gauging their attitude. It was found that adults that had a more positive attitude were less likely than their peers to have coronary heart disease over a 10-year period. Holy cow, they studied them for 10 years. Based on this study, is it reasonable to conclude that a positive attitude causes a decrease in the risk of coronary heart disease? Again, the confounding part is the positive attitude the only stinking thing that would have caused that, or could there have been something else? The answer to this is going to be no. There's no way that you can just say that positive attitude is the only reason that these people were healthier. People with more positive attitudes if you can kind of read through here, they mention exercise a bunch, so it's like they might exercise more often than regular exercise decreases the risk of coronary heart disease. If both of these are true, then we would see a relationship between exercise and coronary heart disease, even if positive attitudes have no effect, is a key phrase today, have no effect on the risk of coronary heart disease. So play the game with the homework program and read through the stories, and see what they're kind of talking about, and use your best judgment to fill those guys out. This is the good stuff right here. Do you want another brownie? Man, I was close to seeing if Chasey would bring all these brownies for us today, but she probably wouldn't have done that. Researchers invited 186 university students to take part in an experiment. While the students were watching a video, they were given brownies to snack on. So, all right, here you go, kids. Watch this video. Here's a brownie. Unknown to the students, the size and the number of brownies differed from student to student. There were 3 different sizes. Check that out. An 8-gram, a 16-gram, and a 32-gram. So, all right, random brownie distribution right here. And 4 different quantities. Could you imagine this? You show up, you ask to watch a video, and they could give you 1 of those brownies, 2 of those brownies, 4 of those brownies, or 8 of those brownies. Researchers measured the total weight of brownies consumed and whether each student finished the brownies or not. So here we go. List the explanatory variables. Here's what we got. The size of the brownie. Like that was something that was explanatory because they had 3 different sizes. So I'll put that, they say, and also list the possible values. So the size of the brownie was one variable that they had in there. It's like, okay, what size brownie did they give them? And the other one was how many brownies they gave them. That's the quantity of the brownies. And then this is kind of a little preview into our statistics part. If there's 3 different sizes of brownies and 4 different types of quantities of brownies, it says like how many different combinations would there be that they could possibly give out. You multiply those together. What's 3 times 4, baby? There's 12 different treatments. Those are the treatments. That's how they treated them. So list 2 of the treatments. Y'all, I'm going to list all 12 of them. I don't care which, 2 you pick, But the way you list them all is it's like, all right, let's say the first person was given the 8-gram brownie, and then there's just 4 different ways they could get a size. So they got the 8-gram and 1 brownie, 8-gram and 2 brownies, 8-gram and 4 brownies, or 8-gram and 8 brownies, right? And then you just kind of did that with the 16-gram. They could get 1, 2, 4, or 8 of them. With the 32-gram, they could get 1, 2, 4, or 8 of them. So that's just multiplying those puppies together. So any of those 2 treatments, they'll kind of have you do that on homework. You've got to just say, all right, I'll take the first one and then use a combo of the seconds. Let me help you with that if you need it. That's like experimenting well, and then let's take a minute to read this experiment and see what kind of problems it would have. So to learn what it means to be a well-designed experiment, let's start with a bad experiment. Mr. Lucklow's class wanted to investigate if caffeine, boom, they're measuring caffeine affects pulse rates. First of all, it does. But how they did this experiment, there's some problems with it, right? So one of his students said, hey, what if we did this for a plan? So this is a student's plan, right? All right, here's what we'll do. Everybody's got to measure their initial pulse rate, right? We'll write that down. Here's your pulse rate. Then we'll give everybody 12 ounces of cola. Cool. Wait 15 minutes and have each student measure their pulse rate again and compare the results. It's not horrible, but it's not good. What are some other factors in here that could go wrong to where if we wanted to see how caffeine affects the pulse rate? I'm going to pause the video and let you discuss with a neighbor. What kind of things did you guys think of? Yep. What if somebody has diabetes or something? Yep, that could be. Yeah, if they have diabetes, that could be bad for them, So what's another thing? They're used to caffeine. Someone like caffeine doesn't even affect them. Like if I was in that group, I got caffeine pumping through my bloods all day long, so my heart rate might not be affected. Cool. What about the design of the experiment? Is there anything in the cola that might also affect heart rate besides caffeine? waited, the time could be a big deal. And then someone said there could be sugar in the cola. Like, is everyone getting the same kind of cola? Is it like, or is somebody getting like super high sugar? Somebody's getting a diet soda. Somebody's getting this, you know. So yeah, there's quite a few things. Here's one thing: if the cola has sugar in it, that could increase the pulse. All right, so that's definitely you might want to write that one down. That's definitely a confounding variable because that's something they didn't account for. It's like, hey, even though caffeine affects pulse, so does sugar, right? You know, so sugar could be bad. I heard you guys talking about something else that could affect the pulse rate during that 15-minute span. What were you guys talking about? What's that? Tachycardia? What does that mean? They just have a high heart rate? I feel that. They're measuring it against themselves, though, right? You know, so it's like, it's not like it's me versus you. It's just like, how was my heart rate? And then I had the, there you go, stress. Stress. There could have been something in that 15-minute span that causes stress. The example that our textbook gave was like a fire drill could have happened right then, or we could have had, like yesterday, they had that hold, that lockdown type thing, you know, and it's like, oh, kids start freaking out. I could have said, quiz time, you know, and it's like, oh, you know, holy crap, you know. So stress could increase pulse rate. Yep. If they totally, because they didn't know they were going to this experiment, they could have been done on caffeine ahead of time, right, you know. So, yeah, that could be an effect, too. All right, and then let's get into that control group first. So we'll go back to the vocab on the front page. A control group is a group provided, oh, my bad. Like, the solution to these problems is to have two groups. One group that receives the caffeine and a control group that doesn't get the caffeine. So what's a control group? Is used to provide a baseline. Used to provide a baseline for comparing the effects on other treatments. In the video that we watched, they did a baseline of, here, hit this without the whiff, you know, they got their score, and then they hit it with the whiff, and they compared the two. So a control group does the baseline. That's the magic word when you get to homework today. It's like, it's all about a baseline. It's all about a baseline. The placebo has no active ingredient in it, but is otherwise like other treatments. So if you were going to just measure, like say you had a pill, and it's like, hey, this is like an aspirin, this is going to make your headache feel better, you know, and that's a real one. The placebo has to look identical to it, so that way they can see, it's like, all right, these, you can definitely tell you don't have the placebo. Placebo effect, we saw a great video of that. The magic word is favorably there. And then the double-blind survey is also important. That's neither the subjects nor those who interact with them measure the response variable known which the treatment and the subject is receiving. So what that's all about is if I'm going to do an experiment on y'all, right, and I have half of you take a real pill and half of you take the placebo, I don't actually know. If I'm given the treatment, I don't know which one's the placebo and which one is the real deal. Somebody else does, like the big puppet master would know ahead of time who got what because they were like in envelopes. So that's a double blind where I don't know and you don't know. So here we go. What devices get customers to conserve electricity? So a lot of utility companies introduce programs to encourage energy conservation among their customers. An electric company considers placing a small digital display in your house to show current electricity use along with monthly projected costs. So imagine that. In your house, there's now a meter that shows you how much energy you're using and how much money that's costing you, right? So that's one thing they did. With the displays, will the displays reduce electricity use? A cheaper approach is to give customers a chart and information about monitoring their electricity use from an outside meter. So y'all have a meter on the outside of your house. You could read that and read the chart. Would this method work almost as well? The company decides to conduct an experiment to compare these two approaches, the display versus the chart, with a control group of customers who is to receive information about energy consumption but no help in monitoring the electricity use. Explain why it's necessary to include the control group. So here's what we got. See if I got it here. Yep. A control group would show how much electricity customers tend to use with no help monitoring electricity usage. This would serve as a baseline. The control group is just like, okay, what would people be using for electricity use without even knowing they were getting monitored? Because you know that if you were told we're going to monitor your electricity, that affects how much electricity you're going to use because you're thinking about it. You know, it's like, oh, I better not, let the TV run while I'm on my phone because they're measuring electricity. I'm going to turn the TV off. So the control group is the baseline of what if people didn't know they were being measured? It's like how much electricity would they use? Fewer calories, more life. Can reducing calorie intake increase the length of one's life? Researchers randomly assigned 46 fancy monkeys to a calorie-restricted diet. That's what CR stands for, calorie-restricted. Or to a control group that received a standard diet and was monitored to prevent malnutrition. It was found that the calorie-restricted group lived longer on average. Why was it necessary to include the control group? So for sure, you better have the phrase baseline in there. So somewhere, the control group, let me see if I got it. Nope, I got to write it in. The control group, sorry, I'm using the highlighter. The control group shows how long the monkeys live on average with a standard diet. The control group is your average monkey life, so they got a standard diet. The control group serves as a, what's the magic phrase for control groups? Starts with a B. Baseline. This control group serves as a baseline. So they just measure the monkey's average diet. That's the control group. So a little caution here. Not every experiment requires a control group. The one with the brownies earlier, it would do no good because they wanted to know how many brownies people ate. And the control group would be like, okay, you got no brownies. Okay, what was that point? We know they ate nothing if they get no brownies in that case. And then here's the last one. Does regularly taking aspirin help protect people against heart attacks? So, hi guys. Little baby kids. The Physician's Health Study was a medical experiment that helped answer these questions. Here's the subjects. The subjects are always people. This many male physicians, that's not a highlighter, but still, that many male physicians. Each of the physicians was assigned to take an aspirin or an aspirin-like placebo. Likewise, of the physicians was assigned to take a beta-carotene or a beta-carotene-like placebo. The physicians were followed by several years, and researchers recorded if each physician had a heart attack or developed cancer. So here's some questions. I'm going to let you treat this. I'm going to treat this guy like it was a drop-down. Explain the purpose of the control group in this experiment. A control group would show the proportion of doctors that either had a heart attack or got cancer while blank. Is it taking or not taking aspirin or beta-carotene? What does the control group measure? The ones that took it or didn't take it? Control group, like that. Not taking. Right? Not taking goes in there. The control group is measuring the people who are not taking the aspirin or beta-carotene. This would serve as a blank, the magic word for control group, baseline. The control group would just measure the average person without any treatments or anything at all to serve as a baseline. It's like, well, this is what it was like for the average person. How did the drugs that we gave them affect them? And then an experiment is needed to show a cause and effect. Cause and effect relationship. When you do the experiment, that shows us a cause and effect relationship because it's like, okay, did this beta-carotene or did this aspirin cause/affect anything? Simply asking the doctors whether they take aspirin or beta-carotene would have been an observational study and might have suffered from confounding. Confounding. Whew, that was a long one. Confounding. All right, we got some homework.